Hello everyone. Today we will be seeing the last topic of the wireless LAN, that is Bluetooth. Bluetooth is a wireless LAN technology designed to connect devices of different functions when they are at a shorter distance from each other. Those different functions such as telephones, computers, printers, all those. Bluetooth LAN is an ad hoc network. Already you have seen about ad hoc network and an infrastructure network. So Bluetooth LAN is an ad hoc network. The devices, sometimes called gadgets, find each other and make a network called as piconet. So this piconet, which we will be studying it later, it is a Bluetooth network, which is a small network which can have up to 8 stations. One is the primary and the rest will be the secondaries. That is what we will be studying next. So here, Bluetooth LAN cannot be large. The applications of this is the peripheral devices such as wireless mouse, keyboards, all these communicate with the computer by using this Bluetooth technology. Also other applications we can see, like in healthcare monitoring devices, these can communicate with the sensor devices by using this Bluetooth. Also in security at home, to connect different sensors to the main security controller, also we can use the Bluetooth. Also, conference attendees can synchronize their laptop computers at a conference by using a Bluetooth. So here, Bluetooth is the implementation of the protocol defined by IEEE 802.15 standard. So this IEEE 802.15 standard defines wireless personal area network, which will be operating in an area which will be somewhat like a size of a room or a hall, somewhere around within a hall or a room. So this is about the introduction to the Bluetooth. Now let us come to the Bluetooth architecture. Bluetooth defines two types of networks. One is said to be the piconet, as I have already told, and the other is the scatternet. So let us see, this is the first one, which is piconet. So this piconet, which is a small net, which is a Bluetooth network, this can have up to 8 stations at the maximum. And one is called the primary and the rest, all the stations are the secondaries. You can see in the figure here. So at the secondary, synchronization, all the secondaries synchronize their clock and the hopping sequence with that of the primaries. The piconet can have only one primary station. As you can see here, there is only one primary station, and communication between the primary and the secondary can be one-to-one or one-to-many. Although piconet can have maximum of 7 secondary stations, and if there are additional stations, they will be in the parked state, and this cannot take part in the communication until they move on to the active state. When these move into the active state, the stations which are active need to go into the park state to take part in the communication. These cannot take part in the communication until they move to the active state. That is very important. That is what you can see here. So remember that piconet is a Bluetooth network, which is a small network. So this piconet, which can have up to 8 stations at the maximum. One is the primary and the rest all are the secondaries. So the rest 7 stations can be the secondaries, and the additional other stations can be in the park state. Next is about the scatternet. Piconets are combined to form scatternets. So secondary stations in one piconet can be primary in another piconet. You can see here, it is a scatternet where one of the secondary of the first piconet is a primary in the second piconet. So secondary station in one piconet can be a primary in the another piconet. So you can see here, fourth secondary of the first piconet acts as a primary for the second piconet. So secondary station in one piconet can be in primary in another piconet. This can receive from the primary in the first piconet and act as a primary and deliver the data them to the secondary in the second piconet. The station can be a member of two piconets here. You can see here, this is said to be the scatternet. So scaternets are nothing but piconets are combined to form scaternets. Next, about the Bluetooth devices, short range Bluetooth is said to be a short range radio transmitter, and the current data rate is 1 Mbps with 2.4 gigahertz bandwidth, and there is a possibility of interference between 802.11b, which is a wireless LAN, and the Bluetooth LAN. And let us move on to the Bluetooth layers. Whatever we have seen is, one is about the piconet and the scatternet. Piconet is a small network which can have up to 8 stations. One is called the primary and the rest are the secondaries. And scatternet as piconets are combined to form a scatternet. Then is about the layers. Bluetooth uses several layers that do not exactly match those of the internet model we have defined. Already which is defined. So you can see about the Bluetooth layers here. So there is a radio layer, baseband layer, and L2CAP layer, which is said to be a logical link. L2 stands for double L. Logical link, control and adaptation protocol layer. So first let us see this L2CAP layer, that is logical link, control and adaptation protocol. This is used for the data exchange on an ACL link. You will see about what are ACL and what are SCO links. ACL is asynchronous connection-less links. Okay. So here the length is, with respect to, you can see the data packet format here. Here the length, which is 2 bytes, which is 16 bits, will be the size of the data, and the channel ID, which will tell about with respect to the communication. This channel ID will be the IDs of the stations, just to identify. Next is about the functions. So the functions of this logical link, control and adaptation protocol is multiplexing and segmentation, reassembling, quality of service and group management. So let us see about multiplexing. At the sender side, it accepts the data from one upper layer protocol, frames them and delivers to the baseband layer. At the receiver side, it accepts the frame from the baseband. It is something called as decapsulation. Extracts the data and delivers them to the appropriate protocol layer, which will be in the upward direction. Second function is segmentation and reassembly. Here the maximum size of the payload is around 343 bytes. Remember, it has 343 bytes, where 4 bytes define the packet length. So the remaining will be 339 bytes. So logical link, control and adaptation protocol divides the large packets sent by application layer into segments and adds extra information to define the location of the segments. So this logical link, control, adaptation protocol segments the packets at the source and reassembles them at the destination. That is segmentation and reassembly. Next is about the quality of service. Bluetooth offers a best effort service. Next is about group management. It is said to be multicasting. This allows the devices to create a type of a logical address between themselves. That is about the logical link control and adaptation layer. Next, let us see about the baseband layer. So the MAC sublayer in the LAN is said to be the baseband layer. Here, the access method used is TDMA, which is time division multiple access. Primary and the secondaries communicate with each other using the time slot, which is of the duration 625 microsecond. This value to be remembered, 625 microsecond, which is a standard duration of the time slot. So TDMA, which is said to be the time division duplex TDMA, which is TDMA. Here, half duplex communication, this is in which sender and the receiver send and receive the data but not at the same time. That is half duplex. So the communication uses different hops, similar to the walkie-talkies, using different carrier frequency. So there is a single secondary communication, which you will see in the figure here, and also multiple secondary communication. So in the single secondary communication, if the piconet has only one secondary, it is said to be the single secondary communication. Here time is divided into 625 microsecond. It should be microsecond. It is a mistake in the textbook. It is not millisecond. 625 microsecond. Primary uses even number of slots. There is only one primary and one secondary, which is single secondary communication. Primary uses even number of slots, that means 0, 2, 4, and the secondary uses odd number of slots, where during the even number of slots the primary sends, during the odd number slot the secondary replies back. It is something like a poll method. Next is about the multiple secondary. Even here you can see this is like a poll select operation. So it has multiple secondaries. It is similar to a poll select operation, which is used in the controlled access method, like a reservation. So one primary sends, there are multiple secondaries. So first it will be polled with respect to the secondary 1, then it is polled with respect to the secondary 2. Even here, primaries will be using the even number slot and the secondaries will be using the odd number slots. With respect to the links, before moving to the frame format, as I have told already, there are two types of links, which is SCO, that is synchronous connection oriented link, and ACL, which is asynchronous connection less link. SCO link used to when avoiding latency or delay in the data delivery is important. Avoiding the delay in the data delivery is important than the error-free delivery. So here it's like just we want to send the data soon. It will not be bothered about the integrity. That means error-free delivery. It's fine if little errors are introduced in the data. In that case, synchronous connection oriented links are used. Your physical link is created between the primary and the secondary by reserving specific slots at the regular interval. This will be used for real-time audio, where the data rate is around 64 kbps. In the case of an ACL link, which are asynchronous connection less links, these are used when the data integrity is more important. That means error-free delivery is more important than avoiding the latency. So if the payload is corrupted, it is retransmitted. So the data rate is here achieved is around 721 kilobits per second. Next, let us move on to the frame format types. So here in the frame format types, there are actually three types. One is a 1 slot frame, 3 slot frame, and the 5 slot frame. So as you can see here, in the 1 slot frame, we have 366 microsecond, which is allotted to that one slot. 259 are used for the hopping. So 629 minus 259 is 366. That is for one slot. In the case of a 3-slot frame, it is 3 into 625 minus 259. So it is 1616 microsecond will be the time. And for the 5-slot, it is 5 into 625 minus 259. So it is 2866 bits, which will be the length of the frame with respect to 1 slot, 3 slot, 5 slot. So 1 slot and it's 240, 3 slot 1490, and 5 slot is 2740. So those are the length of the frame. And with respect to the frame format, first is the access code. So this consists of 72 bits, which are said to be the synchronization bits, and also these are used to identify the primary. It is used to distinguish the frame of one piconet from that of the another, that is the access code. Next is about the header. This header consists of repeated 18-bit patterns. 8-bit part is repeated here 3 times. So here address is 3 bits, which can have where by using which 7 secondaries are defined. Type is 4-bit, which defines about the type of the data. F is for the flow control. If it is 1, that means buffer is full. A is for the acknowledgement. S is for the sequence number. HEC, it is the header error correction, which is 8-bit. It is a subfield checksum to detect error in each 18-bit headers. It has 3 identical 18-bit sections. Next is about the payload. Payload is 0 to 2740 longest, which contains the data or the control information. In case it is a 5-slot frame, it will have 2740 frame long. Next is about the radio layer, which is not there in the slides. Last topic. The radio layer is the physical layer of the internet, which you can see here in the first diagram which was shown about the different layers. So logical link control adaptation protocol layer is defined. Baseband layer, which is same as the max-sum layer, which discusses about the frame format, that is said to be the max-sum layer, is defined. Now last is the radio layer. So it is the physical layer of the internet. The Bluetooth are low power range of 10 meters. So here the band is 2.4 gigahertz ISM band, which is divided into 79 channels of 1 megahertz each. And here the frequency hopping spectrum is used to avoid interference. Here the Bluetooth hops around 1600 times per second, which is here each device changes the modulation frequency 1600 times per second. This should be remembered, and the device uses the frequency for only 625 microsecond before it hops to another frequency. So 1 by 625 microsecond is 1600 times per second. Here the modulation to transmit these bits used is Gaussian bandpass filtering, which is GFSK, which has a carrier frequency, and this FC is given as 2402 plus N, where N can take the values from 0 till 78 because there are 79 channels. So here 1 stands for frequency deviation above the carrier frequency and 0 for the frequency deviation below the carrier frequency. So this is about the radio layer, which is the physical layer of the internet. So what is that we have seen in the Bluetooth is, whatever we have discussed today is, one is about the Bluetooth is a wireless LAN technology which is designed to connect devices of different functions such as telephones, computers, printers when they are at a shorter distance from each other. So gadgets find each other spontaneously and make a network which is said to be piconet. Here the Bluetooth LAN as it cannot be large, and applications are can used in the healthcare monitoring, security at home, and peripheral devices like keyboard, mouse, all that. And the IEEE standard is IEEE 802.15 is a standard which defines wireless personal area networks operable in an area like a size of a room or a wall. And architecture is there are two types, Piconet and the Scatternet. Piconet can have up to 8 stations. One is called the primary and the rest are secondaries. At the secondary, this all secondary synchronizes the clock and the hopping with that of the primaries, and Piconet can have only one primary and it can have 7 secondaries, and which is the maximum. And Scatternet is Piconets are combined to form the Scatternet. Secondary station in one Piconet can be a primary in the other Piconet, which is important. Next is about the Bluetooth devices, short range radio transmitters where the data rate is 1 Mbps with a 2.4 GHz bandwidth, which should be remembered. And with respect to the layers, we have seen already there are radio layer, baseband layer, logical link control and adaptation protocol layer. So this logical link control adaptation protocol layer has got different functionalities like multiplexing, segmenting, reassembling the data, providing the quality of service and the group management. Next is about the baseband layer. So this baseband layer is the MAC sub layer where the primary and the secondaries communicate with each other using the time slot that is 625 microsecond, which is a standard. And also TDMA is used here for the communication, which is TDMA, which is time division duplex, time division multiple access. So there is a single secondary communication and also the multiple secondary communication, which was discussed. Next, where here it is similar to a pole select operation with reservation. Next, also about the two types of links was discussed, synchronous connection oriented link and asynchronous connection less links. Synchronous connection oriented links is used when avoiding latency is important than the integrity. Whenever there is a fast data transmission is required, used for real-time audio, and asynchronous connection less link is used when data integrity is more important than avoiding latency. And with respect to the frame format types, there are 3 types: single slot, 3 slot and 5 slot. And also with respect to the types, your access code, which is for the synchronization and identification, and also with respect to the header, there is an address which defines about 7 secondaries, then about a flow control, acknowledgement, sequence number, and finally about the radio layer, which is the physical layer of the internet. The Bluetooth are the low power range, which of 10 meters, and also we have your band is 2.4 gigahertz ISM band, which is divided into 79 channels of 1 megahertz each. Here frequency hopping spectrum is used to avoid interference. Bluetooth hops 1 by 625 microsecond, that is 1600 times per second. Each device changes here the modulation frequency 1600 times per second, and the carrier frequency is given as 2402 plus n, where n takes the value from 0 to 78, and GFSK is the modulation used here. And in the next class we'll be continuing with the module 3, the next topic, which is connecting devices, and followed by the network layer services. Thank you.